Carbon is not our enemy. As an element, it forms the basis of life as we see it around us. As a gas in carbon dioxide, it helps keep our world warm and has led to the life we are part of. And it can be seen in fuels such as methane, which bring us energy which we can use to do work. But we are out of balance. As with many things, we take, but we do not give back. This has not only led to the climate problems we now face, but it has left our soils impoverished, reducing crop yields, removing their structural stability, and increasing runoff, which leads to floods. What if I told you biochar could remove carbon dioxide from the air, improve the quality of our soils, increase the yields of our crops, and reduce the likelihoods of floods? And that is not all it can do. It can clean our water, be a food supplement for livestock, increase the structural integrity of our buildings, and so much more. All whilst using the waste products that we would otherwise have thrown away. The gases it gives off and heat it produces can also be used by products. Do you want to know more? It has the potential to sequester or draw down gigatons of carbon dioxide every year, locking it away in a solid form that benefits the environment. Biochar in the soil increases the fertility and the water holding capacity. This increases the yields and growth rates and reduces surface runoff, which directly causes flooding. And most importantly, the improved soil structure will reverse the issues of desertification and loss of fertility. We have abandoned a third of all arable land in just the last 40 years due to these issues. We can reverse that. Okay, so what is biochar? Biochar is the carbon-rich charcoal-like substance created by heating biomass or organic matter in low oxygen conditions, a process known as pyrolysis. Almost half of dry biomass weight is pure carbon. If biomass is left to decompose in air, almost all the carbon is lost into the atmosphere within a few years. During pyrolysis, around 50% of biomass carbon is converted into biochar. Of the other 50%, around 2/3 can be released as useful energy. Thus, 1 megaton of dry biomass sequesters and locks away 0.3 megatons of carbon, equivalent to 1.2 megatons of CO2. And it doesn't have to be the stuff we want. It can just be the leftovers that would normally be discarded. Biochar is considered to be carbon negative and a potential climate change mitigation technology because it removes CO2 and simultaneously releases energy. It could be used to filter drinking water, then to deodorize the bathroom, and then to be used in dry latrines where it accelerates the content's journey towards being a usable compost. Or the biochar can be ground down and used as a supplement for animal feed. This not only reduces costs, but it accelerates their growth, raises milk production, and keeps the animals healthier. The waste products, or dung, are carbon rich and benefit the soils that they are used to fertilize, more so than without its addition. Now that is fine for subsistence communities, I admit, although it will likely play far less of a role as the future comes forth. What about the modern industrialized world? Let us consider the production of beer, tofu, cheese and yogurt. These manufacturers send huge tanks of highly acidic whey to nearby farms to spray onto their fields as a low-cost disposal strategy, which can alter the pH of the soil in a negative way. Or maybe the basic washing of fruit and vegetables to remove dirt, leaves, skin and seeds, and the water used during processing for blanching, cooking, cooling, cleanup, fermentation, bottling, and many other essential processes. This water is rarely treated, it is just disposed of into nearby soils and waterways. The problem with this is not the pollution effects of the acidic whey we just considered. Indeed, they are usually low in pollutants, but they are high in nutrients. This is not only a loss we could be using, but once in waterways, this itself becomes a pollutant. However, if the water is filtered through biochar, the resulting water is clean enough to reuse. and the biochar locks away the nutrients and becomes supercharged as a fertilizer. Currently, when this filtration is used, the carbon is shipped to a plant where it is reactivated using high heat processing. Using it as a fertilizer eliminates the need for reactivation and the energy that requires. It reduces transportation miles and, most importantly, reduces the need for chemical fertilizers, which are expensive and energy intensive to make. Never mind that with a soil low in carbon, most of the fertilizer used gets washed straight out into the rivers and ocean, a waste of money and highly polluting. Whereas the biochar holds it in the soil along with the water, improving drought resistance by considerable amounts. So what should we aim to do? We need to source biomass, not from the crops we could use for food, but from non-foodstuffs and existing waste streams, especially those that would, if neglected, generate greenhouse gases, either by being burned or left to decay. And there is plenty of that around. Let's look at some numbers. The total live biomass of the planet, excluding bacteria, is about 560 billion tonnes of carbon. The annual primary production of biomass, both wild and domesticated, weighs in at around 100 billion tonnes of carbon. Now, if we look at just cereal crops, they make up about 2.3 billion tonnes of carbon each year. More than half of that is waste, and there could be many other steps in the chain to make the best use, such as protein extraction from the leaves, fermentation, distillation, or fed to livestock, all with the final stage of carbonisation. Then also consider waste from paper mills, poultry farms, pig farms, coffee grounds and tea leaves. All of them can be used and not just chucked into the landfill or disposed of where they cause pollution in some form. As in rich biochar, it stays in place, it does not wash away or leach out into rivers, it stays put, sucks up water and slowly releases its nutrients over many years. The potential just within agriculture itself is huge, and if they had biochar facilities on their land or local, they could process the waste and put it directly back into the fields with almost zero road miles. They could even link up with local industry looking to filter water such as dairy and beer production, and then put the supercharged biochar full of extra nutrients back into their soil. The ground is richer, able to maximise the nutrient uptake, it holds more water so it can still grow in dry spells, and it floods less and holds the topsoil in place better. This all means the crops are better and able to withstand stresses better. Even if the climate was not an issue, it makes every sense to do it anyway. The last farming revolutions brought us amazing gains and helped sustain a much larger population, but the model was not sustainable. With decades of data and a better understanding of biology and chemistry and how interconnected all the aspects are, we can now look back and see the mistakes that we have made, and we can correct the path we are on to optimize the way things are done and to get better results with vastly reduced waste in a way that truly benefits all of life. But it does not have to stop there. Carbon is the core of so much, and innovation is throwing up new uses all the time. So in the future, there could be robust markets for carbon in foods, feeds, medicines, fibres, electricity, roads, concrete and bridges, and in the very buildings we inhabit, in the plaster, the paints, roofing, insulation and bricks. It just seems to make everything better and stronger. What we have always called waste management has really been organic mismanagement, squandering valuable resources with no respect for their true value. Let us know in the comments what you think of biochar as an ecological tool for a better future. And click like if you liked the video, and hit the subscribe button to show your support for the channel. Thank you for dropping by.